Hello and welcome back. This is Dan, and we're continuing with our inverse functions, specifically looking at quadratic functions. And this is going to be the last example that we do for this one, but it's going to be a bit of a doozy. So we're trying to find the inverse of the function f of x equals negative 3x squared, where x is less than or equal to 0. So first things first, we're going to say y equals to negative 3x squared. We're going to swap our x and our y. So it's negative 3y squared. And now we want to solve for our y. So we're going to divide by negative 3. We have y squared equals x over 3, and this is negative. And now we want to take the square root of this entire thing. So if y equals the square root of negative x over 3. Now, because we're doing x is less than or equal to 0, we're going to put a negative sign in front of this. So our function notation would say the inverse of f of x is negative square root of negative x over 3. Now, we want to try to graph this. So let's see how this comes out. So our original function was minus 3x squared, but our x was less than or equal to 0. So minus 3x squared means that we're going to start here, and we're going to come down there, and it's going to look like this. So our range is going to be y is less than or equal to 0. So now we want to take a look and see what this does to our inverse function. So if you remember, our domain and ranges swap. So we can already say that our domain is going to be x is less than or equal to 0, and our y is going to be less than or equal to 0. And our function for this was the negative square root of negative x over 3. So for this, we start here, and then we go all the way out to there. And this is what our function looks like. So we found the domain and the range, and we found what our functions look like. But what is their point of intersection? And this is going to be a question that you guys might be asked. So how do we find this out? Well, we set their equations equal to each other. So we have negative 3x squared equals the negative square root of negative x over 3. So immediately we can see they both have negative signs. So we can take that out. So now we have 3x squared equals the square root of x over 3. I think you can see what we're going to do next. We want to get rid of the square root. So we're going to take this entire thing and we're going to square it. So that means on the left side we now have 9x to the 4 is equal to minus x over 3. So now we're going to take this 3 out and we're going to multiply this all by 3. And we're going to get 27x to the 4 equals minus x. So now we want to bring this x to the other side, and we get 27x to the 4 plus x equals 0. So you may think that at this point we want to factor, and you'd be right. So we'd have x into 27x to the 3 plus 1. And this is going to be equal to 0. So we're going to find out, when does our x equal 0? So we know at one point it's going to be 0, because 0 times this entire quantity is going to give you 0. But what about the inside? So for that, we're going to say 27x cubed plus 1 equals 0. So we'll have 27x cubed equals negative 1. And then we're going to divide by 27. So we'd have x cubed equals negative 1 over 27. And now we're going to take the cube root of this, and we get x equals negative 1/3. So that means our x points of intersection is 0 and negative 1/3. Now what about for our y points of intersection? Well, that makes it a little bit easier, because all we have to really do is plug it in. So remember, our y is equal to negative 3x squared. So if we put in a 0, we'd get a 0. But what happens if we put in negative 1/3? So y equals negative 3 into negative 1/3 squared. So here, what we get is we get negative 3 into 1/9. And negative 3 times 1/9 is just negative 1/3. So that means our y's are 0 and negative 1/3. So that means that we have 2 points of intersection at 0, 0, and at negative 1/3 and negative 1/3. And that's how you find where these two intersect. But now we want to find what's the average gradient between those 2 points. Well, to do this, you just need to remember what your slope formula was. This is y2 minus y1 over x2 minus x1. So we can plug everything in. We know our x1 and y1s were 0, and our y2 and x2 were negative 1/3. So we have negative 1/3 minus 0 over negative 1/3 minus 0. The zeros can go away, so we have negative 1/3 over negative 1/3. Negative signs can go away, but we can see right here that we're dividing something by itself. So that means that our average gradient is equal to 1. And so this concludes the inverse function series for our quadratics. If you guys have any questions, don't hesitate to ask us, and I hope you guys learned a lot during this section, and I'll catch you guys later.